Hello. So today we are doing this problem called reverse linked list 2. And basically the problem says we are given a linked list and we want to reverse it from position M to N in one pass. So basically we don't want to reverse the entire linked list necessarily. We might given like just a range from M to N and we want to reverse that range. So the example here is with this linked list, M equal to 2 and N equal to 4, such that the indexes start from 0. So we'd have 0, 1. Actually, the indexes start from 1. So we would have from 0. So we'd have 1. Actually, the indexes start from a little bit confused from 1 actually. So here is 2, and so we need to reverse this portion here from 2 to 4. And so that ends up being 4, 3, 2, this portion here that got reversed. So this is the problem. Let's see how we can solve it. So we can solve it in two ways. One way is recursive, and the other one we can do it iteratively. I'm going to start with the iterative solution. So let's get right into it. So a couple of things that are useful to think about and just write down are what are we doing here. So basically our goal is that the end of range, which is the range, when I say range here, I mean from M to N. So the end of range M to N to be, so basically what I'm going to do is we are going to have something like, let's take the list that we have here, right? And so let's take the list. So with this one, we have, just give ourselves some space. Okay, so this is 0, this is 1, and this is 2. And the range, this is our M basically. So this is our start M, and our N is right here, which is, here we have 3, and here we have 4. Right? So, and what we are trying to do is we want to reverse this portion here. So let's call this the element just before the range that we are trying to do. Let's call this element here before, right? So our goal is that the end of this range, M to N, to be which is 4 in this case. Let's call it at N, at position N. To be the next value, to be the next node of before, right? So we want to end up with this, which is so what we want to do here is that the 4, which is the end of the range, we want it to be the next of before, right? We want it to be the next of before value, which is 1 here. So that's one of the goals that we want. And we want to basically traverse until we reach N, and we keep assigning next nodes to be next to before. I'm going to explain this in a second. So in order to get this, to achieve the fact that 4 to be just after 1, so the end of the range to be just after 1, so we'll keep traversing, and we will put 3 first after the before, and then when we get 4, we'll put it after the before. So every time we'll traverse, the next value, we'll put it just after the before pointer, as the next of the before pointer, so that by the end of the range, we will put the last value as the before of as the next value of before. So let me just explain this with this this text here, this drawing here that I draw here. So this P here, this is my before pointer. So this is my before pointer, right? And so the linked list, let's say there are a lot of elements here, a lot of elements here, and a lot of elements here. We don't care about those. What we care about is reversing this range here, reversing this range right here, right? Which is from M to N. This is what we care about, reversing this range from M to N. So we can have this pointer before the start of the range, and then we put a start pointer at the first element of the range, and then we put a then pointer, let's call it t, which is just the next element of the start. And so the invariant here is that t is or then is always next to start. Okay, and so while we traverse, what we are going to do is every time we will take then, which is the next value of start, and we put it before just after before. So for example, here t is then. So what we want is we make the pointer to t to be s, and then we take 1. So we take the then pointer and make it point to start. So this is the linked list reversing, basically. So this is just the reverse step, which is taking the value that was next and making it point to the value that was before it. That's still just reversing a linked list. The special thing here is that we will point the before node to the then node, which is this link here. And we will do that at each step. We'll put the before link to the next. So you can see every time here in each iteration, I'm taking the before pointer and making its next value to be the then pointer. I'm doing that here too. I'm taking the next value of the before pointer to be the value at then, the node at then. And then here too, I'm doing the same thing until we reach the end of the range. And then after that, we don't care about, after that we stop. And so if we keep doing this every time, assign the before pointer dot next to be the then pointer or the node that then pointer points to, then by the end, where the then pointer is pointing to the last value of the range, then we will get that the start of the range here that the before pointer points to would be the last value here. And so that allows us to achieve this goal so that the end of the range is the next node of the before pointer. And so the gist of what I explained here is that we will keep traversing until we reach n, which is the end of the range, and we will keep every time assigning the next nodes, or let's call them the then nodes, to be next to before. So each time I take the next node or the then node and make it the next of before, which is what I'm doing here. I'm doing that here. So that's the step to make sure that the end of the range is just after the before pointer here. And the rest of the operation is just flipping these pointers so that we can get a reversed range. And so that's the first part. The second part is reverse the inner links in the range. And the third part is we want the start of the range before reversing to be the end of the range after reversing, which means that 2 here needs to be the end of the range. So how can we achieve that? So we can achieve that by keeping this pointer start here, and we don't modify start. We keep start as it is. So you can see start is always pointing to 1. And we modify the rest of the values. So we change the then to be before to be next to before, but start stays the same until all of the elements after it are pushed before it, and so by definition it ends up to be the end. So we keep start as it is, we don't modify it, but all the values next to it, we keep moving them from their position to be before that start pointer, because we put them just after the before pointer. And at that point, 1 would be the end. And then we keep just swapping the inner nodes here by assigning, so for example, here we assign the next of 1 to be 3, and then we assign here the next of 1 to be 4, and that's basically all we are doing. This is a little bit maybe confusing, I hope not, but just draw this down and go step by step until you will see why it works. And so with this here, let's try to write what we want. So the first thing we want is to get this before value, this before pointer. And so in order to get there, we will need to do a for loop in range from 0 to m-1. So just before the mth node, we will keep doing before equal to before.next. There is just one case that we need to handle, which is what if what if m is equal to 0 to 1 actually? So it's the first node. Then we wouldn't have a before pointer. And so just to have a before pointer for that case, we will have a dummy node. Let's call it dummy. And that's list node of 0. And then the next of that would be the head. And so before gets initialized to that value. And now we do start equal to, now we start assigning values to these pointers that we had here. And so start is gets to be before.next. So before is here, and starts out to be the one next to it. And so that's before.next. And the then pointer is the next of start. So the then pointer here is the next of start. So that's the next of start. So start.next. And after that, we just need to go through the range. So that would mean for e in range of 0 m-n, this is just going through the range from here, this range here that I drawn here. We can also say from m to n, but this is the same thing. So for that, we can start doing what we said we are doing here. So the first thing we wanted is that the every next value becomes the value next to before. So that means that then that next. So that means that before that next becomes then, right? So every next value or then node becomes the next of before. But the thing is, we want this, when we move it here, we want it to point to the value that used to be the next of before. So we want 2 to points to 1, this here. And so, and the same thing here, when we move the 3 we wanted also to the next to it to be pointing there. So we would say then that next is equal to before that next. So that if we move the next pointer, if we move the then node to be before this one here, we don't want to lose the link to 1. So we want then pointer to point to have its next pointing to this value here. And so that's what we are doing here. And then after that, we just point to it. And the next step is we want the start.next to point. So we want the start.next here to point to the next after then. So we want this one here to point to this one, which is the link I'm drawing here. And so we want start.next to be the then.next. We just have to be careful because then.next we overridden it here, so we don't want that to happen. So let's just move this one up. This, you always have to be careful of overriding pointers here and then assigning them after they've been like replaced. So, and that's just to have the correct order of assignment here. And so the other operation that we need to do is that the then here needs to move to the next one so that we can do the same operation again. So then was at 2, we moved it to 3. So we want to keep doing that until the end. So that means that then is equal to then.next for the next iteration, basically. And then once we do this, we reverse the range. So this here reverses the range. We can just return dummy.next, which points to the head. So do dummy.next. But basically, the gist of what we are doing is that we are doing the usual reversing of the. So the way we are doing it, we take the next value and we put it before, so that, and we put it before all of them. And that way we reverse basically. So let's say you had an array 1, 2, 3, 4, just to make this. So in order to reverse, what would you do? In order to reverse, let's say the range 2, 3, 4, this range. So we will get to 1, and we'll just keep saying, okay, 2, let's put 2. And then we have the next of 2, which is 3. Let's assign 3 before 2. Before 2 and just after 1. And then we say, okay, we have a new one, which is 4. Let's assign it before all of them. And then do 5. And so with this, we end up with this range here reversed. And so that's the same idea we are applying here to linked list. It just gets complex with pointers, but it's the same idea. We take 2, we traverse, we have 2, we put it, we get 3, we put 3 before 2, and then we get 4, and we put 4 before 3. And the way we are doing that is by making it next to 1 and making it before the value that was next to 1 before it. And yeah, just think of it first on an array, and then you can project that to a linked list. Okay, let's run this and see if we get. We have a problem here. The output seems wrong. Yeah, it's probably failed. Yeah. So. Yep, I made a mistake here. Then .next should be start.next. The new then should be the start.next, and not the, because then .next is already overridden here. So yeah, I made the mistake. So then .next is already overridden here, but start.next haven't, so we can just use that instead. So start.next kept track of the then.next, and so that's why we used it here. Oh, I made a mistake here. It's not m minus n is a negative value, so the loop won't run actually. It's the bigger value minus m minus the smaller one. Okay, so this should pass. Yep, it does. Okay. So now let's look into doing the recursive solution. So the recursive solution is, we need our base case, we need our base case, we need to reduce the space that we are calling, so that we can get to the base case. So recurse on a smaller input, and then we need to return, just do the operation, that kind of the recursion operation. And so what's the base case here? So the one base case, we can think of it as one node, or one base case actually in this case, since it's a range that we are reversing, is if m is equal to n, then that means we have just one node to reverse in that case. So nothing to do. So in that case, we return just the node as it is, because we can't reverse one node, its reverse is just the same one. Okay, what is the smaller input then that we need to do? So actually here there are two cases. So case 1, and then case 2. Case 2 has an operation and case 1 doesn't. So just to make this simpler for us, if m is bigger than 1, so we want in case 2 just to handle m equal to 1. And then in case 1, we just want to reduce the space so that we can reach this m equal to 1 case. And so the way we can do that is just by calling reverse between again on head, and we reduce m minus 1 and n minus 1. so that we can get a smaller, we can either get the base case or get this one. But if we do this, that means we have a smaller set, so we have a, so we need to point to that. So let's just keep, so this is not a smaller space, and we need to do head dot next, so that it's really m-1. So new head is head, right? So we need the new head next to point to that. So think of it as we have 1, 2, 3, 4. And if m is bigger than 1, if m is here, which is bigger than 1, then we just can reverse this, and the reverse of it, make it the next of this value here, right? So, and that way we can just return new head. The interesting part, though, is when it's equal to 1. So when it's equal to 1, we're still going to do this. But this time m is equal to 1, so we just want to reverse the rest here, and keep 1 here. And so here we do the same thing we did in the video that I explained about just reversing a linked list in a recursive way, which is basically every time the node tells the nodes after to reverse themselves, and then just tag itself to it. So basically, at 2, I tell my recursive function to reverse this part. At 4, I tell it to reverse. Well, it's 1 node, so I'll get back 4. So at that point, what I need to do here, when I get back 4, I need to just reverse the pointer here, so that it's this way instead. And so if each one of them does it, then 2 here also would say, okay, I have the reverse list, so I just put myself in a reversed way. And then we get here, and it will also say, okay, I have the reversed list, I'll put myself in a reversed way. And the only thing we need to take care of is that we need to return this 4. So we need to keep track of this end here and keep passing it along, so that when we get here, at the end, we can return this 4 instead of this 1. Because this 4 is the head of the reversed list. So we are going to do the same logic for this range instead. So the new head, when we reverse, the new head is this. So that would be when at 2, it would be this, with the head being 4. And so that's what we need to keep track of and return up. And what do we need? We need to do this reversing of the link here, right? Which basically means that we need to say that the head.next .next would be equal to head, right? Which means that the next of, which means for 2 is that, sorry, it's actually for 3. So basically, it means that 2 will put itself at the end, basically. And so that would mean we set it this way, and then we'd say head next becomes this part here. But since we assign it, we need to put it in a value like this, so that we can use it here. And yeah, that should be it. And so let's just take this. Yep, we need to do this. Okay, let's see. Okay, so that passes. Yeah, so yeah, that's it for now. We have 2 solutions, a recursive and an iterative solution. Yep, thanks for watching. See you next time.